Okay, so ladies and gentlemen, you are all welcome to my YouTube channel. Today we are going to look at how to calculate rate law, or how to get the order of the reaction using the initial concentration. So this is a table showing a reaction between nitrogen oxide with chlorine to produce nitrogen oxide chloride. So in this table, we have two different experiments. We have experiment 1, 2, and 3, and we have initial rates of the consumption of the chlorine gas in molar per second. So, but in this case, we have the initial concentration as for NO is 0.13, 0.26, and 0.13. And for the initial concentration of chlorine, we have 0.20, 0.20 again, and then 0.10. So let's look at the experiment 1 and 2. So in the experiment 1 and 2, we have initial rates. We have initial rate of 1.0 times 10 to the power of minus 2 and 4.0 times 10 raised to the power of minus 2. So you can see that the initial concentration of chlorine for these two experiments are the same. So it means that this change of rate of the reaction is due to the change in the concentration of nitrogen 4 oxide in experiment 1 and 2. So now let's going to take the rates equation for the experiment 1 and 2. So the rate equation is going to be rate 1 is going to be rate 1 is equal to rate 1 is going to be K into the concentration bracket of NO. Then we close the concentration bracket power X, then times the initial concentration of chlorine power Y. And then the next thing is actually the initial concentration of for the rate 2. We are going to take rate 2. So for the rate 2, we also have K into NO, then power X, then for the chlorine we have chloride power Y. So now at the end we are going to have this. So we can easily equate this equation for these two different rates. We can equate them. Of course, here we have K, so this K will now take care of this K. So therefore, this implies that we have rate 1. So the value for rate 1 is 1.0 times 10 raised to the power of minus 2. And of course, for the rate 2, we have 4.0 times 10 raised to the power of minus 2. Then is equal to the initial concentration of the nitrogen oxide, which is 0.13 open brackets and close bracket. We have power X, and then we have divided by the nitrogen oxide concentration for the experiment 2, which is 0.26. So you see at the end we now take this and this, and of course for the chlorine we have 0.2 plus the brackets, and then of course we have another 0.2 for the experiment 2. So we have power Y, power Y, and of course this one is the same thing, so this one will now take care of this. And of course, okay, here we have to close the brackets here too. So therefore now at the end we are going to have this one will also cancel this. So at the end we are going to have 1.4 here divided by, of course for this one divided by this, we are also going to have 1.2. Everything here will be in brackets power X. And of course, from the basic knowledge of indices, this one, it can be the same thing as 4 power minus 1. And this one is going to be 2 power minus 1. And then we open bracket, we close bracket, and then we have x here. So of course, 4 is the same thing to say 2 power minus 2. So this 4 power minus 1 is something as 2 power minus 2. And of course, for this 2, we have minus 1 here times x. So we have 2 power minus x. 2 power minus x. So this one will now cancel this. And we now have minus 2 is equal to x. So at the end, we are able to get x here to be equals to 2. So therefore now, we are now going to say x is equal to 2. So therefore, from here, we can of course delete all this. So we can now get, from here we can now get the value of y again, since we are able to get the value of x. So for you to get the value of y, let's consider experiments. Let's consider experiment 1 and 3. So for the experiment 1 and 3, you can clearly see that in the experiment 1 and 3, we have like, for example, experiment 1 and 3, we have 0.13, and of course for the experiment 3, we also have 0.13. So we can see that now the change in the rate of the equation is of course due to the change in the concentration of initial chlorine in experiment 1 and experiment 2. So therefore, for we to get the rate here, we can also going to apply the same thing by saying rate 1 is going to be concentration of nitrogen oxide power x times concentration of chlorine molecule also power y divided by, of course, we have k here, we have k here, and of course we have R1. So for the R2 also, for the rate 2, we're also going to have k is equal to NO, and then we plus power x, and then we have chlorine Cl, we also close it power y. And of course we can equate them. So this x will now cancel this x. So for the rates, for the two rates, rate 1 is 1.0 times 10 raised to the power of minus 2 times 10 raised to the power of minus 2. And of course, for the 3, that is experiment 3, the rate is 5.0 times 10 raised to the power of minus 3, which is also equals to the concentration of NO is 0.13 divided by 0.13. Then we have close it, and we have power x here. We have power x, and then also this one, we also have power x. And then for the y, we have the open bracket, we have 0.2, and we close the bracket and divide by 0.1. So we have power y here, and we have power y. So this one will just scale, this one will now cancel this, and of course, when we now take this time this and we divide it by this, at the end, we are going to have 1. We are going to have 1. Okay, yes, we are going to have 2. That we take this and divide it by everything here, we are going to have 2. And then of course now 0.2 divided by 0.1, we are also going to have 2. power y, 2 power y. So here is the same thing as power 1. So this one will now cancel this. So we now have y is equal to 1. So x here is equal to 2 and y is equal to 1. So what is the order of the reaction with respect to each reactant? So to get the order of the reaction, you are going to sum, or we to get the order of the reaction, we are going to sum x plus y. And of course, our x is 2, and then our y is 1. So we now have 2 plus 1 is equal to 3. So this is called a third order reaction. This is the third order reaction. So now, what is the rate law? What is the rate law of the reaction? So the rate law of the reaction now, since we know the order of the reaction, so the rate law of the reaction is now going to be rates R is equal to K into NO, and of course our X, we found it as 2, so we have NO power 2, and then we have Cl, Cl2 power 1. So this is the rate law. So we now answered 1. The order of the reaction is 3, and the rate law is this. And then, so the next thing is, what is the value of the rate constant? So to get the value of the rate constant, that is K, is also simple. So we can take any of this. So now we have the rates as 1.0 times 10 raised to the power of minus 2. So we have is equal to, so we take this, and then we have NO, the concentration of NO is 0.13. 0.13. So we have our K here, our 2 times the chlorine, which is 0.2, or 1. So how are we going to calculate this? It is simple. And then going to be a subject of the formula. So we have 1.0 times 10 raised to the power of minus 2 divided by 0.13 square times 0.2 is equal to K. We now have K is equal to 2.9, 2.95, 2.96, 2.96. So this is the value of the rate constant. So ladies and gentlemen, if this is the first time you are coming to my YouTube channel, please subscribe. And this is how to calculate the initial concentration from, how to calculate rates or order of the reaction from the initial concentrations. Thank you for watching my video.